So this is question number 10 in the series of 150 interview questions. What we are going to do in this question is we are going to count the minimum number of jumps through which we can reach from index 0 to the last index of the array nums. This question is very much similar to the last question that we did, question number 9, where we were checking whether we can reach from first index to last index. Only we have to return true or false, but here we have to count how many jumps are needed and we have to count the minimum jumps. For example, at 0th index you can make maximum 2 jumps. You can make 1 jump also, 2 jump also. For let's say you are making 2 jumps, right? You are reaching to the point index 2. At 2 again you can make maximum 1 jump. 3 also you can make maximum 1 jump and you reach the last index. So how many jumps are required? 3. So maybe this is one way of doing, but this may not be the minimum way of doing. Let's see, from 2 I am making only 1 step jump. Then from 3 I am making all 3 jumps and I am reaching the last index. So I am making 2 jumps, which is the minimum number of jumps we are making. Just once go through the previous video, you can see there is a recursive way of doing also, but we followed one approach, similar approach of greedy algorithm we are making here. We are just introducing one new concept, that is counting the jumps as well. Okay, here you can see. So this is the technique. Farthest we were already calculating. Farthest means the maximum index you can reach from any particular point. Here I am introducing the new concept to count jump. So you have to keep in mind when you are jumping. You are jumping when you are at 0th index. For example, you are at 0th index, you reach 2nd index. So at this point of time, from 0, the farthest index you can reach is 2, right? Or it can be 1 also, it can be 2 also. Farthest is 2. So at 2 again you will feel the need of jumping, right? That means here you have to make the another jump. Correct? So when you are at an index where you have used all the farthest value, the maximum value you can reach, then you have to jump again. If we are making minimum jumps, we have to keep this in mind, because we are trying to find out minimum jump, not maximum jump. So we will jump only when there is a need. So for that, what I am doing is, farthest is the maximum index we can reach, and current and means where you are right now, and jump will count the number of jumps. So what we will do is, we have written a condition. Farthest we will calculate every time. So we have written a condition, if I is equal to current end, that means the place where you are reached currently, when I will reach there, you will make a jump. See, right now all are 0, right? So first of all are 0. Then you are calculating farthest value, which means maximum of 0, comma I plus nums of I. I value is 0, nums of I value is 2. So farthest will be incremented to value 2. So what we are saying is, if I equals to current and you are at 0 and I also at 0. So you will do jump plus 1 and current and you will increment to farthest. That means now you have jumped till 2nd index. Understand this concept. You have jumped, you are sitting on this point now. Okay, now no need to jump. Simply increment index. Index will be at point I now. Okay, again farthest value will be maximum of current farthest, which is 2, comma I plus nums of I. That means 1 plus 3, 4. So farthest new value will be 4. You will compare. If I equal to current end, is it equal? No, it is not equal. I is 1, current end is 2. Simply increment the I. Now you are at I, which is 2. Current end is also 2. First of all, let me calculate farthest value also. Farthest will be maximum of 4, comma I value 2, nums of I value 1. So 2 plus 1, 3. No, it will not be updated. Farthest will remain 4 only. But right now you are at 2 index and current end, that means the place where you are sitting is also 2. So what you have to do is you have to increment the value of jump, and current index you will make again farthest. Farthest means the maximum point from which which is attainable for you at this point of time. Okay, which is 4. So at this point of time you can jump till 4. So then we will make another jump to current end 4. 4 means you have reached the last point now. So when you have reached the last point, now next you will not jump. No need to jump again. So we will break the code when current end is greater than or equal to n minus 1, and we will return the number of jumps that we are making. So this is the program. I hope you have understood. Simply to minimize the jumps, we are jumping only when I is equal to current end. That means the point where you have reached is equal to the index, only then you are jumping. And when current end is equal to the last index where you are going to reach, you will stop incrementing the jumps. Clear? Similarly, we can see, here we can see the LeetCode solution of this. I will add this solution in a py file for you. I hope you have understood the concept. If you have understood the concept, you can write yourself also. It's the same code snippet that I've written there. I have used the same code logic here also. I hope this is clear for you. Thanks a lot. Subscribe to my channel, go through this series, and let me know if there is any other question which I can make a video on. Thank you.